The last part of these transformations that we want to look at is what is new to you, which these are stretches and compressions. So if we start off taking a look, I just want you to get this information down and kind of just take it all in, because we will be working with them, and I think by doing that you'll be able to grasp them a little bit better. So if we take a look at first with the horizontal transformations, so let's start with that horizontal stretch. It's talking about horizontal. When we have that horizontal piece, that's going to still affect that x coordinate. The x coordinate is the one that's changing because it's horizontal. Now if we're stretching horizontally, what that's doing is it's taking those points and stretching it away from the y-axis, which is why this is becoming, if we start off, your original function is this blue one here. And what it's doing is, so for example, if our coordinate is 4, 0, and we have a factor of, say, 2, that means that we're going to take that x coordinate, because the x coordinate is going to change, and by stretching it means that our b value is going to be bigger than 1, and we're going to multiply that b value. So it's going to go from 4, 0 to 8, 0. So that's where we end up getting this new graph here that's been stretched wide. Now on the other hand, a horizontal compression, we are pushing those points towards the y-axis. So if we have that original function right here, and we have 4, 0, what's going to happen is with a compression, that b value is going to be between 0 and 1. This is going to be some fraction value. And so in this case, say the factor is 1/2, we would take that 1/2 and we would multiply it by 4. That would give us that 2, 0, which ends up resulting in giving us this really skinny function because everything is being pushed towards. Now if we think about it in the same terms with a vertical stretch, going back to the second column, vertical implies the y coordinate changing. Once again, it's just like the horizontal is x, vertical is y. And here we're pulling away from the x-axis. So if we have this original function here, we're going to have that a value bigger than 1. And when we do that to our y, it's going to end up pulling each point away vertically from that axis, which is going to make it really tall and really skinny, which is how we get this new function here. Now likewise, a vertical compression, if we're looking at these compressions here, then that's still the y coordinate changing. This time we're going to take this function, we're going to push each point towards the x-axis, or sorry, towards the towards the x-axis, which what that means is we're going to have that a value between 0 and 1. Once again, that's going to be our fractional value, and we're going to multiply that y value, which is going to take that, compress it, and we're going to compress it down towards the x-axis, and that's what's going to make this drop really low and get really wide, because we're pushing everything towards that x-axis like we're flattening it out. Now one of the big things, like I said, I want you to remember is that horizontal stretches and compressions change the x-coordinate. Vertical stretches and compressions change the y-coordinate. That is the big key here when you're looking at these. And so if you can remember that, it's going to make your life that much easier. So now I have an example here. Like I said, I just want you to get this down, and we can always come back to this because we're going to get a lot more practice with this when we look at parent functions. So we have here this graph of this function that goes from left to right. Oops, I apologize. Let's go ahead and try to get a pen here. It goes down, and then it curves up a little bit, and then it goes flat. And we're going to horizontally compress this by a factor of 1/2. Because it's horizontal, that means we're changing the x-coordinate. So I'm going to look at that means that my y-coordinate is going to stay the same. So my original ordered pairs are -1, 3, and 0, 0, 1, 1/2. I'll show you. Let's not go with 1 because that is going to make our lives a little bit more difficult. So let's go with 2, 2, and we can go with 3, 2. Now, because this is a horizontal compression and we said by a factor of 1/2, we're going to multiply all of our x-coordinates by 1/2, which gives me a new x-coordinates of -1/2, 0, 1, and 1 1/2. So when I go to graph that, we have now -1/2, 3, squishing it in tighter, still 0, 0, 1, 2, and 1 1/2, 2. So it's still going to shoot out this way, and then it's going to curve down a little tighter and shoot up a little. Oops, I missed there. Let's try that again. There we go. And so as you can see, it gets that much tighter in there, which creates this horizontal compression because compression means we're going to squish it towards the y-axis.